In 2.6, we kind of just repeat the things that we've done in 2.5, which is solving inequalities algebraically in more detail. But the thing is, there's so many different types of questions for algebra that I really want to show you a gradient from the really easy questions all the way to the very difficult kind of questions. So we're just going to go over lots of examples in this video. Okay, so the warm-up. One of the things that you're really going to need to know how to do is solve an equation. So that means I need to know how to isolate for x, bring everything over to the other side, and do the opposite operations. So negative becomes a positive 6, and then we're going to divide by 5, which is the opposite of multiplying by 5. And then you get x by itself. So you've now isolated for x. Same thing as if you have your variables on either side. So just bring all of your variables onto one side. It doesn't really matter which side. And then bring all your numbers onto the other side that have no variables. Then you're just going to solve. So 4 minus 3 is 1m, and then you have 7, and a negative 6 makes a 1. Okay, so inequalities are very similar. The only thing is we do have this extra little thing. So let me get out my highlighter. If you have a statement like this, 2 is less than 5. Well, that makes sense. 2 is definitely less than 5. But if you multiply both sides by negative 2, so multiply this side by negative 2 and this side, do they still hold true? Like, does this statement still make sense? Well, whenever you have multiplied or divided by a negative number, it actually reverses the symbol. So when we say that, we mean something like this. I'm going to multiply this by negative 2, and I'm going to get negative 4. This one is going to become a negative 10. So does it still make sense that negative 4 is less than negative 10? Not really, because this is a smaller number. So if anything, the pointy part should face the negative 10. Okay, so negative 4 is actually greater than negative 10. All right, so that's something new that we didn't know before. And what I'm going to show you now is some examples. So let's see an example of that. All right, here's a regular type of question. It's one of the easier types of questions you'll see on a test or a quiz. And that's where you just start solving. There's no equal sign, so there is an inequality instead, but you do the same thing you did before. Bring the 6 over to the other side, it becomes a positive. Put these guys together and you get a 9. And that last step where you start doing the division, be careful. If you have a negative, it's going to change the symbol to the other direction. But since we're dividing by a positive 5, notice that the symbol didn't change. Okay, so we have x by itself, and it's going to be less than 9 over 5. Okay, so that's the final answer, but if we ever wanted to write it in interval notation, x is any number that is less than 9 over 5. So x belongs to negative infinity all the way to 9 over 5. It doesn't include the 9 over 5, so notice that it's a round bracket, and that's because there's no line underneath the inequality. Okay, so since we have a line over here underneath the inequality, we're going to have a square bracket. The infinities always have round brackets though. Okay, so here's a more difficult question, but only slightly. Bring the 3 to the other side. We want to start isolating for that t. So negative 2t is over here. 5 minus 3 is going to be 2. And now we have to do that division piece. Okay, so dividing by a negative 2 now, that's going to change our symbol from a less than or equals to a greater than or equal to. Okay, because you've now divided by these negative numbers. So this is going to become t by itself, and now it's greater than or equal to, and this is going to be negative 1. So t is any number, it belongs to anything from negative 1, including negative 1, all the way to positive infinity. All right, so how can I make this a little bit more difficult? Well, I could always put variables on either side, so that's not a lot more difficult. You just bring them both onto one side and then have your numbers that have no letters on the other side, just like the warm-up. Okay, so your symbol should not have changed, but then we always have to be careful right at the end when you do your division. It doesn't look like you have to do a division in this case though, because it's a 1m. So 1m is less than or equal to 1. So the way I read that was I read it as the variable towards the number. Okay, so if I wanted to rewrite it again, I'll show you. M, if I wanted to write it first, m is right here. Then the pointy part is facing the m, so I'm just writing it in an opposite direction, and then the 1 would be on the other side. So this statement is the same as this statement. Either 1 is greater than or equal to m, or m is less than or equal to 1. They're saying the same thing. So if you want to read it in this direction, then you can go m belongs to anything smaller than or equal to 1. So that's why we're writing it like this in interval notation. Okay, now even more difficult. These are weird ones where you actually see the inequality twice. And I'm just going to denote that in red so that you can always see it. But it looks a little bit complicated, and it really isn't. It's the same thing. Just expand the brackets. Okay, so I'm going to get 6x plus 12, and then the negative 2x, and negative 2 times 1 is negative 2. So all I did was I took the brackets away, and everything on the outside just stays the same for now. Let's simplify this. So I got, what is that? 6x minus 2x is 4x. 12 minus 2 is 10. And now we're going to start to solve. So let's get rid of this 10 first, and we have to minus 10. If we minus 10 in the middle, we got to minus 10 on either sides as well. So we get new numbers on the outsides. Okay, and now that 10 is gone. So the last step is to divide by 4. Well, again, if I divide by 4 in the middle, I've got to divide by 4 on either end as well. So I'm going to get x by itself, but this is now a 5 and that's now a 3. So x is between 5 and 9. If I wanted to write that as an interval notation, what I would do is I would go, therefore, x belongs to, okay, so 5, including 5, so that means square bracket 5, and then 9 including 9. So I'm going to go 9 and then square bracket as well. Okay, now how can I make this even more difficult? I mean, this stuff is not that hard, but if we put it to something that's like a grade 12 advanced function level, now we got to get into those interval charts. So I showed that to you in 2.5, and I'm going to try to go over it quickly because then I'm just repeating myself really. These types of questions are easier when everything is factored for you already. You can solve for your roots easily, and then you can have your x-intercepts. Now your x-intercepts have to be in order because we're going to put them into the intervals that go on the top of our chart. So negative infinity all the way up to the smallest number. Then that smallest number to the middle number is the next interval. That middle number to the last number is another interval. And then the very last interval is going to be that last number all the way to infinity. Notice that this is an equal to sign right there, and that's why we have each of the square brackets. Okay, so if there was no equal to sign right here, they would all be round brackets. And again, these guys are always round. Okay, so these intervals are going to go on the top of our chart right up here. The actual f at x, so each of the brackets of the f at x, go right here on the left-hand side. So those guys multiplied together will create our f at x. And we want to know, what does the f at x look like? Like the final function, all of these guys together, what does the graph look like, and where is it greater than or equal to 0? So we start just randomly picking numbers in between each interval. So in this interval, I might pick a number like negative 100, because negative 100 is between these numbers. And I'll sub it into my x, so negative 100 minus 2 is a negative number. Negative 100 minus 8 is a negative number. And 2 times negative 100 plus 5 is a negative number. So within this region of the graph, a negative times a negative times a negative, I'm going to have a negative part of the graph. All of my y values are going to be negative. Okay, so it's going to be below the x-axis. So I'm just going to do that for each of the intervals, and I get the rest of the pluses and minuses. So my graph is negative in this interval, positive in this one, negative in this one, and then positive in this one. And I just want to know, where is it positive, so greater than, or equal to 0? So that's this one and that one. That means that these two intervals are my answers, and that's why we write them right here, and we unite them with a u. Okay. Okay, so this one looks the same, but it's basically a little bit different just because I put a coefficient in front. You're going to do the exact same thing, solve for your x-intercepts and put them in order. Those are going to be your intervals, so negative infinity to your first number to your second number to your third number, and then your third number all the way to positive infinity. Now these guys, when you put them into the left-hand side, the difference is this still is included in the left-hand side. It's very important actually. Okay, so make sure you stick that -2 to any of the brackets. I mean, it's right beside the first one. You may as well put it beside the first one. And then this one's going to go here and so on. Okay, and you do the exact same thing. And then you answer the question. You say, well, which of these final intervals is less than 0? So in other words, a negative. That would be this one and this one. So your answers are these two intervals. See? All right. Okay, the very last one, which is the most difficult, is obviously if they don't factor it for you. In that case, you're going to have to do the factoring, and that is through, I mean, I can see there is a common factor of -3. Let's take that out first, and then you might have to do some long division. So long division as in you're going to have to find a factor, do long division to find the quotient, and then you're going to have to break up the quotient. So you're going to have to do all of that work to actually put it into factored form first before you start making the chart. Okay, so what we have here is our x-intercepts. Notice that there are two x-intercepts that are the same and then one x-intercept that's different. So I actually have the answer here, but I'll show you how I got the answer. What we have is our intervals, negative infinity to -3, so that's the first one. This number to this number, so that's the second one. And then 1/2 to positive infinity, which is the last one. And we have square brackets because of the equal sign. Okay, now I got a little bit lazy. I didn't list all of the different factors, but you know that this should go together on the left-hand side, and this one should also go on the left-hand side. But this is a lazy man's way. I mean, if you want to just do it really quickly, you don't want all those pluses and minuses, you can always just write f at x and write the final answer. Okay, so I found out that I have a plus and then a minus. Now, if I actually looked at that through the graph, it's saying from negative infinity to -3, negative infinity to -3, it's positive, it's above the x-axis. And then in this interval, it's also positive. So notice that it touched and then it went back up again instead of going underneath. All right, so that's why I'm getting a positive and a positive. And then this negative means it's going to go past the x-axis downwards. All right, but all I really wanted to know was, where is it less than or equal to 0? Which is this interval, because that is the part that is less than or equal to 0 in terms of y values, and that is our answer right here. Okay, so I'm hoping that you had some experience now as to what kind of different questions you can get on a test or a quiz, and they really can build from level of difficulty of easy all the way up to something that is quite a bit more work.